High temperatures occur during combustion in the cylinders of an engine. Some of this heat is released into the environment with the exhaust gas. Some of it is absorbed by the engine. Because these temperatures would damage the engine, cooling is required. One option is air cooling. The cooling effect from the airflow during travel can be improved with a blower blowing air via the cooling fins. Because water is better at absorbing heat than air, most engines are water-cooled. In this case, the cooling liquid, a mixture of water, glycol and various additives, absorbs the heat from the engine block and cylinder head and releases it into the ambient air via the cooler. A pump is required for transporting the cooling liquid. This water pump, also known as coolant pump, circulates the cooling liquid around a closed circuit. Mechanical water pumps are located either externally in their own pump housing or are flanged directly on the crankcase. They are usually driven directly by the engine. This direct connection to the engine speed means that the power consumption increases with the speed. But even during idling, sufficient engine cooling must also be guaranteed for all operating states. Even if you get caught in a traffic jam on a hot summer's day after driving at full throttle on the motorway, the engine must still not overheat during idling. Conventional water pumps are therefore oversized for most operating states. There are different approaches to reducing the power consumption of the pump to reduce the fuel consumption and emissions. With switchable water pumps, for example, which are disconnected from the drive intermittently, or with throttle-controlled water pumps with flat control. With the variable mechanical water pump with electromagnetic clutch, the impeller of the pump turns significantly slower than the drive when the clutch is not supplied with power. The full delivery rate is only applied when the clutch is energized. Fully variable electric coolant pumps work independently from the vehicle engine. They have the advantage that their installation location can be freely selected and that they only deliver at the rate that is actually required. To bring the engine up to operating temperature quicker, for example, the electric coolant pump initially delivers only a little or not at all. The engine wear when the engine is cold is reduced, and the catalytic converter starts working sooner. The electric coolant pump can also be operated after the engine has been shut down for post-cooling to prevent hot spots during start-stop operation, or to use the residual heat in winter. Pierburg is a leading manufacturer of water pumps for the international automotive industry. Pierburg produces over 7 million mechanical water pumps alone each year for use as original equipment and is a technology leader in the field of electronic coolant pumps. For more information, contact your local MotorService partner directly or visit the website shown.